Welcome everyone. We are discussing integration of trigonometric function. Today I will discuss integration of type sine to the power nx cos to the power nx dx. Case 1. M and n are both odd. Put sin x equals to z or cos x equals to z. No need of thinking. So put either sin x equals to z or cos x equals to z. Now application. Integration sin cube x cos cube x dx. So both are odd. So transformation is sin x equals to z or cos x equals to z. So cos x dx equals to dz. Now look, express this sin cube x unchanged and 1 cos x unchanged, and cos cube x, this is 1 minus sin square. So sin x equals to z. So sin cube x unchanged, 1 cos x dx equals to dz. So cos x into cos square x. So 1 minus sin square x. So in terms of z, z cube into 1 minus z square dz. Now this is z cube minus z to the power 5 dz. So z to the power 4 by 4 minus z to the power 6 by 6 plus c, where z equals to sin x. Z equals to sin x. So if both are odd, no confusion. So problem number 2. Sin cube x cos to the power 5x dx. We can put sin x equals to z or cos x equals to z. But since power of cos x is greater, so it will be easier if you put cos x equals to z. So sin x dx equals to minus dz. What advantage you are getting? Cos to the power 5 unchanged. So this one is sin x, and sin square x is 1 minus cos square x. If you put sin x equals to z, then cos to the power 5 is 1 minus sin square x whole square. So to avoid it, we are putting sin x equals to z. Now this is z to the power 5, 1 minus z square into minus dz. So z to the power 7 minus z to the power 5 dz. So this minus is absorbed. So z to the power 6 by 8 by 8 minus z to the power 6 by 6 plus c, where z equals to cos x. So this one is very simple. Now case 2. M is even. M means power of sin x is even. N is odd. So M is even. So you have to put, if M is even power is on sin x. So put sin x equals to z. If m is even and n is odd, even power equals to z. Then exactly same procedure. So look, sin to the power 4x cos cube x dx. So m, power of sin x is even. So put sin x equals to z. So cos x dx equals to dz. Now exactly same. So sin to the power 4x unchanged, 1 cos x dx unchanged. This is 1 minus sin square into cos x. So cos cube x, 1 minus sin square into this. So z to the power 4, 1 minus z square dz. So z to the power 4 minus z to the power 6 dz. So z to the power 5 by 5 minus z to the power 7 by 7 plus c, where z equals to sin x. Where z equals to sin x. Next, suppose cos to the power 5. So power of cos x is odd. So cos to the power 5 x dx. Actually it is sin x to the power 0 into cos to the power 5x dx. So power of sin x is 0, that is even. So put sin x equals to z. So cos x dx equals to dz. So cos to the power 5, cos to the power 3, cos to the power 7. So cos x dx unchanged. So 1 minus sin square x is cos square x whole square. So 1 minus z square whole square into dz. Now if we expand it, it is in standard form. So indicating z minus 2 by 3 z cube, 1 by 5 z to the power 5 plus c, where z equals to sin x. Now case 3. Sin to the power nx, cos to the power nx. n is odd, n is even. So 1 is even, 1 is odd. So even power. So here n is even. So even power is on cos x. So put cos x equals to z. So our main aim is to put the integrand in standard form. That is why we are putting the transformation. So sin cube x cos to the power 4x, sin cube x cos square x, sin cube x sin to the power 5x. So 1. Power of cos x is even. So cos x equals to z. So sin x dx minus dz. Now look, cos to the power 4. So keep it at first. So sin cube 1 sin x unchanged, and sin square x is 1 minus cos square x. So z to the power 4, 1 minus z square into minus dz. So z to the power 6 minus z to the power 4 dz. Minus is absorbed. So z to the power 7 by 7, z to the power 5 by 5 plus 3, where z equals to cos x. So very simple. If you know the rule, you can put the exact transformation. Otherwise, you have to put hit and trial method. So sin to the power 5x dx. Sin to the power 5. So no cos. So sin to the power 5x, actually cos x to the power 0 dx. No need of writing it. So power of cos x is even. So cos x equals to z. So sin x dx equals to minus dz. Now sin to the power 5, 1 sin x unchanged, and this is sin to the power 4, 1 minus cos square x whole square. So exactly same, minus dz. So 1 minus 2z square plus z to the power 4 dz with negative at the beginning. So next step is minus z minus 2 by 3z cube 1 by 5z to the power 5 plus c, where z equals to cos x. So this is case 3. Now case 4. Sin to the power mx cos to the power nx dx. When m and n are both even, so express the given trigonometric function in terms of multiple angle. We have already solved this type of problem, sin square, sin 4, cos 4. So sin to the power 4, we have already solved it in previous section. So sin to the power 4, so power of sin is even. So no cos, so cos x to the power 0. So power of cos x is even. So express it in terms of multiple angle. Suppose problem number 3. Sin to the power 4x, cos to the power 4x. No transformation. So 2 sin x cos x whole to the power 4, and it is balanced by 1 by 16. You have to express it in terms of trigonometric function. Multiple angle, sin 2x to the power 4 dx. So this is problem number 1. Now this is again 1 by 16, 2 sin square x, 2 sin square not x, this is 2x whole square. We know a formula. So it is balanced by 2 square, it is 1 by 4. 1 by 4. So next step is 1 by 64. 1 minus cos 4x whole square. Yes. Now expand it. So 1 by 64. 1 minus 2 cos 4x plus cos square 4x dx. Now it is integrable, it is not integrable. So express it in terms of multiple angle. So 1 by 228, 2 minus 4 cos 4x, 2 cos square 4x dx. Now 1 by 128, 2 minus 4 cos 4x, obviously integration, and 2 cos square 2x, 1 plus cos 8x dx. Now look, all are in standard form. So we can integrate it term by term. So 128, so 2 plus 1, 3. So 3, integration of 3, so this is 3x. 4 unchanged. 2 and this is 1. 3, integration of 3 is 3x. 4, this is sin 4x by 4. This is sin 8x by 8 plus. So 4 cancel. So you get answer. So express the given trigonometric function in terms of multiple angle. Next look, problem number 5. Sin square x cos to the power 4x dx. So 2 sin x cos x whole square. So sin square x is balanced, cos square x is balanced. So 1 cos square x. So we can write 2 cos square x because we know formula of 2 cos square x. So it is balanced by 1 by 8. Look at 2 sin x cos x. So sin square x, this is cos square x, this is cos square, cos to the power 4. Now 1 by 8, this is sin square 2x, This is 1 minus cos 2x dx. Now this is 1 by 16, 2 sin square 2x. So 1 minus cos 4x and this plus 1 minus cos dx. Now multiply it. 1 minus cos 4x plus cos 2x. This is cos 4x into cos 2x dx. So it is in product form. So last step, 1 by 32, 2 minus 2 cos 4x, 2 cos 2x, 2 cos a cos b. So cos 6x plus cos 2x. Total. Now simplify. So only you need idea of formula of multiple angle. So 2 cos 2x, this is minus cos 2x. So plus cos 2x minus 2 cos 4x minus cos 6x. So all are in standard form. Integrate and you get result. So this is case 4. Now case 5 is the most important part. So you may get one problem in board or in competitive exam. So case 5. Now case 5. Sin to the power mx cos to the power nx dx. M plus n even negative. Put tan x equals to z or cot x equals to z. So our main aim is to put the integrand in standard form. So that is why we are putting this transformation. So problem number 2, dx by sin to the power 3 by 2x cos to the power 5 by 2x. So in standard form, sin this is at numerator, cos is at numerator. So what is m? Minus 3 by 2, n minus 5 by 2. So m plus n minus 4 equals to even negative integer. So put tan x equals to z or cot x equals to z. Tan x equals to z. Sec square x dx equals to dz. So condition is fulfilled. So tan x equals to z. Now this is not given in tan form. So to make it tan, so sin to the power 3 by 2x, cos to the power 3 by 2x. To make it tan, so cos to the power 5 by 2x and balancing factor is cos to the power 3 by 2x. So this is balance. Now next step is, look, next step. So dx by tan to the power 3 by 2x and this is 8 cos to the power 4x. So this is sec to the power 4x, sec to the power 4x by tan to the power 3 by 2x dx. Now we know tan x equals to z. So sec square x dx equals to dz. So 1 sec square x. Keep it separately. And this is 1 plus tan square x. So tan to the power 3 by 2x. Now put the transformation. 1 plus z square by z to the power 3 by 2 dz. Z to the power 3 by 2 dz. So divide term by term. Z to the power minus 3 by 2. 2 minus 3 by 2. So z to the power 2 minus 3 by 2. So z to the power half into dz. Now this is in standard form. Second one is also standard form. So z to the power 3 by 2. So z to the power minus 3 by 2 plus 1 by minus 3 by 2 plus 1. Z to the power 3 by 2 by 3 by 2 plus c, where z equals to tan x. So m plus n, even negative integer. Put tan x equals to z and express the function in terms of tan. Next, 3 dx by, this is in terms of cos. So cos to the power 4 by 3x, sin to the power 8 by 3x, sin to the power 8 by 3. So what is m? Minus 4 by 3, n minus 8 by 3. So m plus n minus 12 by 3 minus 4, even negative integer. So our condition is satisfied. So even negative integer tan x equals to z. So sec square x dx equals to z. Now you have to express it in terms of cot or tan. So dx by sin to the power 8 by 3x by cos to the power 8 by 3x. Cos to the power 4 by 3x as it is, and balance it by this. And what you are getting, look, it is in terms of tan. So tan to the power 8 by 3x, and this is 8, 4, sec cos to the power 4x, cos to the power 4x. So it is cos to the power 4x. Now exactly same, this is sec square x, and this is 1 plus tan square x, tan to the power 8 by 3x dx. Now tan x equals to z. So 1 plus z square into dz by z to the power 8 by 3. So z to the power minus 8 by 3 plus z to the power 2 minus 8 by 3. So minus 2 by 3 z. Now this is our main m. Anyhow, you have to put the integrand in standard form. So this is z to the power minus 8 by 3 plus 1, minus 8 by 3 plus 1, minus 2 by 3 plus 1, minus 2 by 3 plus 1 plus 3. So where z equals to tan x. Simplify and you get result. So today, through this video, we have learned how to find integration of this type, sin to the power mx, cos to the power nx. For different cases, m and both odd, this is number 1, m is even, n is odd, number 2, m is odd, n is even, number 3, both are even, number 4, this is number 5. M plus n equals to even negative integer. So you complete the rest of the problems. So thank you for today.